Welcome everybody in the lecture hall, welcome everybody on Zoom, welcome everybody from the future. Today we will finish this part, namely starting with the XML syntax, because we already covered JSON, and then we'll continue with white column stores that are a very powerful way of storing large quantities of data, including JSON and XML, but in a more structured way than cloud storage or HDFS. Before we start, I'd like to ask you a question on the Clicker app to make sure that you're all with me. Here it comes. What is not stored on the name node? So this is, of course, the Hadoop distributed file system, aka HDFS. So what is not stored on the name nodes? 3 of these are stored on the name node, and 1 of these is not. Let's see if we get 100% of correct answers on that one. Looks like it's stabilizing. We look at your answers. So I noticed that the number of answers is less than the people in Zoom and in the lecture hall. So if you don't know, look at the address here, eduapp-app1.ethg.ch. This is where you can go, or you can install the Edu app on your mobile phone. All right, so we are close to 100%, 94%. This is indeed the correct answer. Where are the replicas of the blocks stored? Everybody at the same time on the data nodes, exactly. You understood everything. And the rest, the other 3 are stored on the name node. This is metadata information. So if we only have the replicas of the blocks, all we have is zeros and ones, but we don't know how to reconstitute the puzzle, right? So the other 3, the file namespace, the mapping from the file path to the block IDs, and the mapping from the block IDs to the list of data nodes, this is to reconstruct the puzzle and get all the data. Okay, so now let me switch back to the slides. And we'll continue where we left. So to put again the context, we've studied how to store data on cloud storage like S3, Azure Blob Storage, HDFS, and so on. But at that point, what are files or objects? It's just zeros and ones. And now we want to use this to store data sets, right? And the data sets, they can be in a binary format or in a textual format, and we are starting with the textual format. We saw last time how to map text, so characters to zeros and ones with encodings. So now all we need to worry about are text documents, but not any text documents. These are text documents that must satisfy a few rules. We call that well-formedness. And the well-formed rules correspond to a language of choice. It could be XML, it could be JSON. There are others, of course, but this is the idea, right? JSON, I already showed to you. There are these 6 building blocks: objects, strings, booleans, nulls, numbers, and the 6th one, arrays. Yes, exactly. So 6 building blocks. Thank you. So, and you can combine them in any way you want, meaning that if you have arrays or objects, then inside the arrays or objects, you can put any other values, right? The only things you cannot use to nest are the string, boolean, null, and number, because of course, these are atomic, so you cannot put anything below them, right? Okay, so let's look at the other one. Which is XML. And then I'll show you also, well, I showed you a bit last time, but how that maps to tables in particular cases. The slides do not seem to work. That's normal. That's the cover slides. And I was just summarizing what we did last time. Yeah, nothing to be sorry about. Maybe I was confusing. All right, so let's continue now with the elements. So just like for JSON, there are building blocks. Now, XML is more complex than JSON, and I'm going to shield you from that complexity. I'm only going to show you the most important aspects of XML, just what you need in order to store data. The first building block is called an element. Elements are basically, you can see them as zones, just like you enter a city and you leave a city. So you basically enter an element and you leave an element, right? So the opening tag means that you enter the element, and the closing tag means that you leave the element. It's just like parentheses or curly braces, right? You have the start and the end. And inside, between the tags, you can have anything. That's the nesting, right? Then you can have other elements, you can have text, you can have plenty of things in between. But you have the opening and the closing tag of the element, just like you have an opening and a closing curly brace for objects, an opening and a closing square brackets for the JSON arrays, right? So opening and closing tag, and the empty tag at the bottom, that's only because we are lazy. We are so lazy that if there's nothing in between, and we don't want to bother opening and closing, then we just have this shortcut where we put the slash at the end. We don't have to. It's also fine to use the opening and closing with nothing in between, but if you're a bit lazy and want to save some space, then you can use the shortcut version, the empty tag. All right, so that's the first one. The second one is called an attribute. An attribute is basically a key value pair. A key, in that case, at, and then a value, which is in double or single quotes, right? So the attributes can only go to specific places, namely either in opening element tags or in the empty tags, meaning that you can have, you see, in that case, this is an empty, the slash is at the end, so that's an empty element, and I put a key and a value in there with an equal sign. So I put it in there, basically. But you can also put them in here, in the opening tab. That's fine, too. Not here. That's not OK. It doesn't make any sense, right? Because you want to associate the attributes with an element, so either here or here. This is one attribute, but you can have as many as you want. It's basically a key value model. Yes, again, a key value model, just like cloud storage. But of course, now the values are super small. So a key and a value, and you can have as many as you want. It's not allowed to repeat the keys, right? So you cannot have duplicate keys per element. It must all be unique. But in a different element, then of course you can have reuse the keys. Okay, so that's elements attributes. The third building block is text. There is a difference with JSON. In JSON, the atomic parts, we have these four basic types, right? We have strings, numbers, booleans, and nulls. In XML, at the syntactic level, we only have text. That's it. It's a sequence of characters, and that's text. All the thing with recognizing types, because of course you could have text that contains numbers and so on, but that is done later at the data modeling level, and we'll look in 2 weeks, well, after the Easter vacation, at how we do that. Otherwise, it's just text when you read XML, okay? And the text goes in between tags. You can even mix and match text within the tags. Who already knows HTML? Many of you, right? This is kind of HTML, but stricter. HTML allows you to kind of sometimes not get things quite right, and it's not going to complain too much. XML is extremely strict. Just an example. In HTML, the attribute values don't have to be quoted. In XML, they do. If you don't quote them, then the processor will complain, right? So you can see it as HTML, but stricter, but also more general, because HTML is just for web pages, but XML is for any kind of data you want, right? So the tag names can be absolutely anything. So elements, attributes, text, and comments. JSON doesn't have that, actually, but we can have comments. Now, comments look a bit, you're going to say strange compared to other languages. You know, for example, in C++, it's a double slash, or you can have this slash star and then star slash at the end, also in Java. Then in some languages, you have comments with a sharp sign. In other languages with %. You know, it's basically just human language that you can write in there. That's not technically part of the data. And you can write anything you want. Comments are typically meant, in the more general case, to communicate between humans, right? You prepare the data set and you write a few comments in there. This is for whichever other human being is looking at this and wants to understand what you did. But this is only half of the truth, because in fact, we also started to abuse comments for communicating with machines. For example, you might have heard of JavaDoc or this way of putting documentation in the comments. And then it's actually computers that are going to extract that in order to create beautiful and fancy looking documentation pages, right? But there is a difference between XML comments and the comments you have in Python or C++ or Java, is that in C++, Java, and so on, typically when you parse to compile, you lose the comments, they go away. But in XML, an XML parser can actually show you the comments, so you can actually see them when you consume XML. Now, why this smaller than, exclamation mark, dash, dash, and then dash, dash, larger than? Like, why is that so complicated? It's just historical reasons. Technically, XML is a simplification of an earlier, much more complicated language that was called SGML. SGML was basically used by the publishing industry to store data like books and so on, but it was extremely complex. And at some point, there was a working group who took a subset of that, much smaller subset, and they created XML out of that. Sometimes when you have these weird sequences of characters, these are just remains of SGML that they kept for backwards compatibility, but this is how it is. So don't be too much surprised by why we arrived at that. This is just how it is, right? Okay. So these are the 4 building blocks that you can find inside. And the 5th is technically what you see at the very beginning of an XML document. That's called the text declaration. That's just what you could have on the first line that basically tells you, hey, that's an XML document. And by the way, it's encoding with UTF-8. Now you know what that is. This is how you map the text to the zeros and ones. And it tells you version 1.0. You don't need to worry too much about that. There are 2 versions. There's 1.0 and 1.1. But the differences are so minor that many people don't really mind between the two. The differences really have to do with some internationalization aspects. But the 1.0 is already quite international. So you don't have to worry too much about the version. All right, so this is what you might have at the beginning of a document. Now, what is the smallest documents you could imagine in XML? It would look like this. You would have the text declaration, and then you would have an element that in that case is empty. Now you could make it even smaller than that. You could have an element that has only 1 letter in its name, then it's even shorter. And since the declaration is optional, you can even remove it, right? So technically the smallest XML document would be smaller than a/greater than. That's the smallest you can ever have. All right. Now I put this green mark on the right to say, yes, this is well-formed XML, right? It means that whatever text you see on the screen can successfully be parsed as XML, okay? And usually when it can, then you start adding colors. That's called syntax highlighting, which many editors allow you to do. All right. Now, this is a counterexample. This is not well-formed XML. And the reason is we have 2 elements at the top level, 2 of them. There is foo, and then there is bar, because see, they are empty, both of them. This is not allowed. In a well-formed XML document, you must have exactly 1 top-level element, exactly 1, not 0, not 2, exactly 1. Inside, you can have other things, but the top-level one must be only 1. This is fine. In that case, there is a top-level element, which is the name of the top-level element. Foo, right? The outermost elements. You see? This is the outermost element. It starts here, it ends here, and this is nested. This is inside, in between the opening and the closing tag, we have another element. So here it's fine because there's only 1 at the top level, which is foo. This is not okay because here we have text that is in the wild, outside of the top level element. That's also forbidden. The text can only be inside elements, in between tags, in between an opening and a closing tag. So this is not okay. This is okay here you have text. It's inside an element, so that's fine. And as I said, you can even mix text with elements, right? So in that case, you have foo that is the top level element. And inside foo, you have a bit of text, then you have an empty element, and then you have again a bit of text. That's totally fine, right? That you cannot do. Why? Because you cannot have an element inside the opening tag. You can have elements in between the tags, nested inside, but you cannot have an element inside the tag itself, right? So that you cannot do. Okay, it has to be here, but not here. So this is fine. This is also not fine. You cannot put the elements inside the attribute values. That's not okay. We'd have to escape them. I'll explain to you, but you cannot have elements in there. The elements can only be between the opening and closing tag, right, in here. This is fine. Here, I just removed this is no longer an element. I removed the smaller than sign. Who is following? Okay. Now, you might see sometimes, especially if you saw HTML, you probably saw this doc type HTML thing. This is not really important. It's basically a line that tells you something you already know. Basically, doc type document tells you this is an XML document and the top level element is called documents. Well, you know anyway, right? You look at document, you see it, but still, it's redundant, but it confirms that this is a document. A top-level element called documents. Okay, so this is why you have this doc-type HTML on web pages, because you have this HTML top-level elements as well. We already saw this doc-type HTML somewhere? Some of you, right? Okay. Just go to a website, any website, and go to view source. You will see it. That's a good exercise. The browser allows you to view the source of any website. Okay. So what can appear where? This is what I already told you, just summarized. Elements can appear exactly once at the top level, between other element tags as many times as you want. It can nest, but not inside an opening element tag. The attributes can only appear inside an opening element tag or an empty tag, right? And the text can only appear between element tags, neither at the top level nor inside an opening element tag, because that's only attributes in there. Okay. Here, I'm also saying something I already said. Within the same element, you cannot have twice the same key, right? So here I have two attributes that are called foo. That's not okay. That wouldn't be well formed. You have to have different attribute names, different keys. So foo and bar here is totally fine, foo and bar, but this is not okay. This is not allowed, right? Not in the same elements. This is also not fine. It's just like, you know, when you write a complex arithmetic expression with addition, multiplication, and parentheses, you need to pay attention to where you put the parentheses, right? When you open a parenthesis, you must close it somewhere else, and then you must be careful in the way you open and close your parentheses, right? It's the same thing here. If you have A and you close it here, then you have a problem because in between you just open B, but you don't close it, right? This is not okay. You cannot, you have to close in the reverse order, right? So if you open A, then you open B, then you first must close B and then close A, right? Okay. Next, what about special characters? Because in the text, you might have special characters that are smaller than. So this, in fact, you can have on websites because you might have JavaScript code that executes, and then you might have a smaller than sign. But here, smaller than really means smaller than. You really want to compare two things. But the problem of the smaller than character, the angle bracket, is that you can confuse it with a tag. And in fact, it's very confusing for a processor that's trying to open the XML file. So it's forbidden. You cannot have this smaller than character inside the text in XML. This is not okay, but you can escape it. Escaping means you replace it with something slightly more complex, but that means the same. So this means lower than LT. You just need an ampersand and a semicolon. That's HTML legacy, as I already told you. So this is how you escape. You already know escaping probably, because you probably already saw in Java, C++, many languages, you need to escape the quotes with a backslash, for example. Probably already saw that, or on the command line. So this is how you do, and every time you have a common way of escaping. In JSON, it's actually a backslash to escape special characters. All right. there are only 5 characters that you can escape and that are predefined. Only 5. Only 5. This is LT for lower than, GT for greater than, apos for apostrophe, you guessed it, quote for quote, and M for ampersand. Right? So these are the 5, there's nothing else. Now, if you know HTML, that might surprise you because in HTML, there's many different escape sequences. The most famous one is NBSP, which is a space that you can't see. But in XML, there's only these 5. So that makes it easy, right? You just need to learn these 5 and you're done. All right? A bit of history on the ampersand. Does anybody know where that comes from? So the English alphabet now today has only 26 letters, but it used to have more. And in particular, some of them are still for example, in Icelandic, you still have this th character and so on. So it used to be in the English alphabet, but then it was replaced by th. So there are examples like that. So they disappeared with the time, but there is one of them that actually survived for a bit longer than the others, and this is this character there, this ampersand. And it was used. It's actually, if you're French, it's actually an A, which is a translation of ET, ET, but ET written in some stylish way kind of gave you that symbol. And what happens is that it was used for end. In German, I think you use a plus in order to mean end. It's very common in company names. And then it was put at the end of the alphabet. And so when you teach that in private school, in primary schools, you recite the alphabet. So A, B, C, D, blah, 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 X, Y, Z, end, right? Because it's after the Z. But then it's weird. You say X, Y, Z, end. That doesn't sound very good. So what the teachers decided with time is to make it a bit nicer for the children. So they say, since it's by its own at the end, they started saying, okay, W, X, Y, Z, and per se, end, right? And by itself, ends, and per se, ends. And then when you recite the alphabet, you start reciting it faster and faster and faster. And then when you recite this faster, it's like W, X, Y, Z, and per se, and M per se, ends became ampersand. That's why it's called ampersand. This is a true story. In fact, if you look for textbooks in the 19th century, you will see the ampersand at the end of the alphabet, right? So now you have a way of remembering the word ampersand, if you didn't know it. It's a contraction of end per se, end. Okay, so that was closing my parenthesis of history. So now that we have these 5 characters that we can escape, as you might imagine, if I have an attribute with the double quotes, then I cannot have double quotes inside because otherwise I wouldn't be able to decipher it. So what do? I escape it. How do I escape quotes? Well, it's one of the 5, right? You see, ampersand quote semicolon. So I just put this ampersand quote semicolon and that's it. That escapes it. So of course, once I have parsed my XML and I process it in my memory, then I'm going to actually see a quote sign, right? The escaping is replaced. But in the syntax, in the file, you will see this ampersand QUOT semicolon. So now, how do we escape this element? If I really want this sign, then I use the LT escaping, right? So instead of this smaller than in front of element, I put ampersand LT semicolon. That takes care of it. The greater than and the slash, you don't need to worry about. This is fine. What you cannot have is the smaller than, because that confuses the parser. The greater than will not confuse it. Okay, but many people also escape the greater than just for cosmetic reasons, because it looks nicer. So this is the summary of what you need to escape where. In text, you must absolutely escape the smaller than and the ampersand sign, right? You have to escape them. In double quoted attribute value, you must escape smaller than the double quote and the ampersand. And in single quoted attribute value, you must escape the smaller than, the apostrophe, and the ampersand. And I put a few examples in there. You see at the top of the screen. So this is fine, this is fine, this is fine. Here, that's an escaped smaller than, that's an escaped ampersand. Here in that attribute, which is double quoted, this is fine, this is fine. This is an escaped double quote. This is an escaped smaller than, an escaped ampersand. And here that's a single quoted attribute, which is totally fine too. Then it's fine to have a double quote and a greater than inside, but you must escape the apostrophe, escape smaller than, and escape the ampersand. This document is totally fine. That's a well-formed XML document. And once you have parsed it in memory and consume it, then the escape sequences will be replaced with the actual characters that they stand for. Who is with me? All right, so now you can decipher these XML documents. It's easy because there's only 5 escaping sequences, so that makes it easy. Okay, now a few words about the names. The elements can have a lot of different names, but there are a few rules, and this is kind of common sense, and if you know a bit how to program, this shouldn't surprise you. For example, an element name cannot start with a digit. It's the same in Python or in many programming languages, right? When you have a variable, it cannot start with a digit. It has to start with a letter, with the underscore, but not with a digit. Then you cannot use the smaller than sign in an element name. You can also not escape it because that's a name, so you can only escape text or attribute values, right? So here you cannot even escape it with anything. You just are not allowed to have this in an element name. The two at the bottom, foo, 1, 2, 3, 4, and underscore bar, that's totally fine, right? So you can have special symbols. The dash is also allowed. The point is also allowed, and so on. Now, why did I put this XML on the side of the disallowed things here? Right? Because XML is 3 letters, right? So why can you not call your element XML? Well, it's technically not that it's forbidden. It's more that it's forbidden to you. The only people on the planet who are allowed to create element names that start with XML are the people who work in the W3C consortium, who defines the standards for the web and so on. So this is reserved to themselves. So it doesn't matter if it's uppercase, lowercase, a combination thereof, you are not allowed to create element tags that start with XML. But a confusion that arises every year is that some of you try it in Oxygen. So the software, I will show you how to download it. So they put that in Oxygen, but then Oxygen doesn't complain that you created an element that's called XML. Well, the thing is that Oxygen has to be future-proof. It might be that in 10 years, the W3C defines elements that start with XML, but they must work with Oxygen. So this is why it will not complain. So this is just something you need to know, that you cannot, there's sun, so I need to do something about the sun. How do I close? I think it's the ones. Let's start with this one. Should take care of it. I think that should be sufficient. Yes. So we just have the sun who is paying us a visit in the lecture hall. So we need to make sure that we can still see the screen. Okay. All right, so this is at the bottom, this is allowed. At the top, this is not allowed. And this is a summary of what is allowed and not. So all the letters of the alphabet, lowercase, uppercase, this is all fine. The underscore, this is all fine. The digits, yes, but not at first. You cannot start with a digit. The colon and the dash and the points are also fine, but also not at the beginning, right? That has to be later. Okay, and the rest is just forbidden, all the other characters. Okay. Everybody with me? Okay. Now, what about namespace? Because in the examples that I gave to you, it was spread over multiple lines. In fact, I also did the same with JSON. Well, the answer is that it doesn't really matter. So you can actually nicely display, that's called pretty printing in computer science language. That's called pretty printing. It's more like a convenience for human beings to see the structure, right? So here it's nicely printed with the, I open on a line and I close on another line. And here I nicely indent like this to show the structure. It's optional, but human beings like that. What typically happens, and you can do it in the Oxygen software, is that if you copy paste some XML in there that is not nicely formatted like that, you can press, I think, Apple Shift P or something, but you can take in the menu, and the software is automatically going to nicely pretty print it like this. So it's very, very convenient to to immediately see the structure. And this is actually who already sees some sort of tree structure in there on the right. Right? Some of you. In 2 weeks, I'll come back to that. There is actually a tree structure. That's the whole point of XML and JSON. All right, so that's XML like JSON. You can nicely indent like that. Okay, then there is a part that I'm going to quickly skim over because I removed a lot of slides. I didn't want to bother you too much with that. It's called namespaces. So I only have a few slides left. The idea of namespaces is just that sometimes you might have people who use XML for different purposes, and then they are going to use the same names for the tags, even though they don't mean the same. For example, the word client could mean something in the context of networks when you connect to a network, like an AGFS client. But a client could also mean something in customer relationship management. The problem here is that it collides, right? How do we distinguish these two? And this is why we have namespaces. And in fact, namespaces are a little bit like family names. It's just like if there are several people who are called Peter or Mary or John and so on, then you don't know who this is, right? There are probably thousands or millions of people called with these names on the planet. How do you disambiguate? Well, with family names and perhaps even with middle names, right? So this is the same here. We disambiguate with namespaces. So I'll directly show you how this is done. So this is an XML document that doesn't use any namespaces. Now, this is how we add the family names. The family name is technically this http://www.doris3.org 1998 mathml. This is the family name for everything that does math. It's the mathematics language, mathml. And what we do is we are not going to repeat the family names all over the place. I mean, when you are in your family, you don't call each other with your family names, right? All the time, right? You use your first names only. So here, what we do is that we take a shortcut, M, for the family name, and then we just use M. And we have this M colon, that's like the family name in front of the first name, like this. And this XML, it starts with XML. So this is one of these reserved cases that I told you about. XMLNS means XML namespace. It just says we're going to use the shortcut M, the prefix M, as a shortcut for the mathml namespace. You can also do it without any shortcut if you just want to implicitly say that if you don't have any family name that it implicitly mathml, you can do it as well, right? So these are the same document, in fact, because it doesn't matter. Okay, so what happens is that you map this M to the namespace, to the family name, and whenever you see M math, then you know that M actually means the namespace. Okay, the prefix doesn't matter. All of these are exactly the same thing because the prefix is only a shortcut for convenience. What really matters is the namespace, right? And now it's beautiful because people all over the planet can define their namespaces. Why this HTTP thing? Because you cannot just type that in your browser. It's just because everybody has the possibility to buy domain names. And so basically, if you buy a domain, then you can, by convention, use that domain for your namespaces, right? Nobody enforces this, but kind of a hidden convention. All right. And so in a document, you can have multiple namespaces. In that case, example.com/bar and example.com/foo. You can bind them to different prefixes, and then you can use the prefixes whenever you want in the document. And then it means that every element now has a family name, right? And typically, these are 4 examples. On the top left, you don't have any namespaces because there's not XMLNS anywhere. This is what I showed you first. On the top right, you have one default namespace. Just with this XMLNS attribute, it automatically puts everything in that namespace. Then on the bottom left, you have an example with one prefixed namespace that's equivalent to the one default namespace. By the way, it doesn't matter if it's the default namespace or if it's prefixed, but it's a different syntax. And on the bottom right, you have 4 namespaces, and they are bound to 4 prefixes, and we use them throughout the documents, right? And people can also do that sort of things, but I say, no, don't do that. This is too messy. This is impossible to decipher. So let's do it the Swiss way. If you use namespaces, you nicely put them at the beginning of the document. Alphabetically ordered is even better, and that's it. And then you have your whole list of namespaces, all tidy. Okay, but that's all I'm saying about namespaces, because I don't want to confuse you too much. In the exercises, in the models, we will not have namespaces. And also when we validate data, we will not use namespaces. Just know that they exist and they are very convenient in order to nicely classify the elements that people invent. You can do that as an offline exercise. This is basically a text document that has a lot of issues. And you can try to spot them if you want. It's a good exercise. But the best way to spot them is technically, so these are actually the mistakes, is to go to this site. Go now, actually, if you have your laptops. Right now, go to itshop.ethg.ch, go to that page right there, log in with your ETH credentials, and go to, I don't know where it's like, service catalog, maybe, and look for a software product and type Oxygen XML Editor 26. Probably it was released for you as well. It's free of charge because you're a student, so ETH paid for it. They were very nice to us. It's very convenient. You can use that editor in order to parse XML and JSON documents, to validate XML and JSON documents. You can even navigate them. It's super useful for the projects that you might have also for your semester thesis or master's thesis or anything, right? And it can be useful for you to study because then you can write text in there and it automatically shows you if that's a well-formed XML or JSON, okay? So I encourage you to download it, right? Because if we don't use it, they are going to stop providing us with the license. All right. So this is very, very useful for the exercises. And what happens if you fix? So this is an example where it fixed. Don't worry about the entity thing that's just advanced and you don't need to do that. That's for declaring your own escape sequences. But that's basically the same fixed. And because it's fixed, now I have all the colors. And by the way, the colors here was Oxygen's work. As soon as it parses, Oxygen will use all of these colors to display it nicely to you. All right. So a wrap up. Why are we doing all of that? Well, XML and JSON are a syntax that allow us, are syntaxes that allow us to exchange and store denormalized data. You remember that denormalized data means it can be nested, you can have missing attributes, you can have additional attributes and so on. But in the particular case of a flat homogeneous table, you can use XML and JSON as well, right? It's just a special case. So this is a table, and this is now what the XML looks like. But now that you know the XML syntax, that should be easy to you, right? You have sale, that is one row, the one marked in red, and you have 4 attributes: product, price, customer, quantity. Now, if you do it for every line, you can have a sales. It's very common to use the plural form and singular. So you have sales that contains the whole table, and sale in the singular that repeats for every line. Yes, you can repeat elements, totally fine in XML. And then inside every cell, you have the four columns: product, price, customer, quantity. I was careful not to say attributes to not confuse you with XML attributes. Okay, for whom is it natural to map the table to this? Right? It should become natural with time, right? Then this is another example where it's pretty printed, because here it's not pretty printed, but here it's pretty printed, right? Now I even put the doc type sales that tells us something we already know, namely the top level element is sales, and so on, right? So take some time to understand that, right? Offline, that this is just an XML equivalent of that table, just like there is a JSON equivalence. But now the really interesting part is that now we can nest tables, and that we cannot do with the CSV syntax. I have a table in a table. In XML, it's easy because you can have an element in an element in an element in an element. So you see how I managed to nest that table with orders, nested in sales. Well, look at this. This is one table order with orders in the plural form, right? And then one order, one order, one order, one order, one order, one order, these 3. So this here is my table orders. Nested inside a sale element, so that's that row, itself nested in the sales element for the whole table. So you see this idea in XML that you model a table with a single element that has a plural form for the whole table, and then a list of elements with the singular form, sale, 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 or order, order, order. I'm not in the British Parliament, but anyway, this is what you get, all right? You can model nested data. Then XML or JSON, it's really just a matter of taste. The best way to start a troll in an internet forum is to go there and ask if XML or JSON is better, and then you will see the avalanche of messages telling XML is better, no, JSON is better. And then the people who are actually, I think, the more right ones who will tell you it depends. And the right answer is really it depends. That depends on the use case. Okay. There are other syntaxes. YAML is one of them. It's one of these things that start with YA, right? Yet another. It means yet another markup language. I think the sun is starting to even bother the green screen now. Right. There you go. Okay. So this is YAML. But I don't need to say much about it because you probably already are able to parse it, right? You see, there are similar to objects in JSON. There is the idea of key values, right? Code CH, name Switzerland. You even have the idea of an array. You see these bullet points here, right? This is kind of an array here. So you have objects, you have arrays, you have nestedness, and so on. So this is YAML. And you have many, many other languages that might get invented. YAML is actually gaining in popularity, especially for people who deal with clusters and Kubernetes and this sort of software, right? So they love YAML. Why? Because it's even simpler than XML and JSON for humans, because you don't even have curly braces, angle brackets. You can have them, but you don't have to. Okay, so this is YAML. Okay. Yes? So we will see that after the Easter vacation. So basically, the types or the domains in XML are handled with schema validation. So you can basically define a schema, and in that schema, you can say that birth date, for example, has the domain date, or that, for example, is physicist has the domain yes, no, Boolean, and so on, right? But this is something that is done later. You basically have first you parse XML, and then you validate it. This is something, as we will see, that's specific to big data. Because if you look at relational databases of the 70s, what happens is that you cannot put any data in your table if you have not first said what the domains are, right? So from the 70s, this is how it worked. In big data, we are more flexible with that. It is possible to first drop your data as it is in your data lake, so in S3, in blob storage, in HDFS, and you can worry about the domains later, right? So this is quite kind of the different way that this can be done. And one of the reasons is simply that data can be very messy at very large scale. So first, you get the data that you have, you need to clean it up. And the process is that once you have cleaned up your data, then you can say, okay, now this is this domain, this is this domain, and then you can validate it. Okay? Does it make sense? Okay. I think you deserve the break. So we are going to take a 15-minute break. I'm done, actually, with the syntax. Now you know XML, JSON, and so on. You should use Oxygen to get familiar with this. I'll come back to XML and JSON for the purpose of validation and drawing trees after the Easter vacation. And then I'll show you that, in fact, who heard data frames? Pandas? Python? It's very buzzword. Well, we'll arrive to data frames. If we start with JSON and we add validation, we actually get data frames. It's magic. So this is, but then you'll have a theoretical understanding of data frames. Okay, so I'll see you in 15 minutes, and we'll start with white column stores. Thank you.